All right, welcome back, everyone.
Matthias, maybe you should like pre-announce today's meeting.
What's that?
Maybe like you should pre-announce like today's meeting or like be a moderator of the discussion of today's meeting.
Sure. Welcome to the, is it the third one already? I think
it's the third one, yeah.
Yeah, the third daily sync, the third daily sync of, yeah, us trying to make sense of the memory use of GitLab. So yeah, should I share the document and we can go through yesterday and today again?
Yeah, I think sharing the doc would be.
All right, I'm gonna share my screen. Okay, so I can assume you see the agenda now. All right, let's just, yeah, go ahead.
I'm first on the list. Let me quickly go through my points. So yesterday I was continuing with Puma in single mode. So I really wanted to check PSS because previously I was only checking like just residence set size. So I found that single mode, at least in Intel, operates better. And for me, the difference was 250 megabytes quite consistently for a single mode version.
That's awesome.
But the issue, I really spent some time to measure it in a, like under load, but I wasn't able to fix metrics, to be honest. So I kind of decided to pause this issue since Camille also noticed that there is a difference for a single mode. I think we had enough on this, so maybe fixing metric.
Yeah. That's interesting. So I'm not too sure I understand, because if in single mode, what is shared in single mode? Because there are no processes to share anything with?
No, nothing is shared in single mode. I mean.
Okay. Wait, so what is the 230 megabyte difference?
If we sum up PSS of clustered mode, like master and workers, so it will be more than 1 gig. But if we see of the usage of single mode, it will be around 800 and something megabytes.
I'm not sure I understand. So what does PSS mean if you have a single process?
I think
it's
for a single
RSS,
process,
right?
Yeah. For a single process is basically RSS. We could not even look at PSS. PSS is important for like forking model,
right?
Which we use in cluster.
Yeah, that's what I'm trying to say. I don't think it makes sense to look at this.
No. I mean, mode. It
doesn't
but
mean anything.
I just use the same as measurement. So for a single mode, we could look into RSS because it's like basically the same as PSS in what this mem gives us.
I mean, maybe there are pages shared with like other random Ruby processes maybe that are running on the system. I'm not totally sure, but you can tell by the, like, this is the.
Yeah, but you could see like it's not a huge difference. Yeah, it's not a huge difference here.
Yeah, it's clear why, right?
Yeah, of course.
There's only one process, so there's nothing.
But the difference is visible on cluster because we are forking. Yeah.
So just to really make sure we understand what this means, this is a completely virtual value. This has like no basis in any like real, like, so the more, so this will go down if you spin up, if you have like, these are 2 workers, right? So if you double the number of workers here, this will half. Okay.
Not this will have, I think, but the additional part of this will have, because there is a process memory plus this additional, the shared part will have, So the delta will have.
Because this is just distributed over,
this
is the portion that we just randomly, kind of, well, not randomly, but like that we can, if we distribute the shared memory over the number of processes that are sharing it, right? So.
Yeah, I understand this. So basically, like if you take this 381, so basically there is this like self process memory component, let's say some X megabytes, and 381 minus X is something that is divisible. Like if we multiply by the amount of processes will get this 837, I guess.
So it kind of like shows that like per single cluster, we need around 150 megabytes of additional memory right now. Because this is like the USS, what is telling you is like unique set of the memory that is used by that process that is not shared with anything else.
Mm.
So it means that like each cluster, it modifies or like allocates additional 150 megabytes. Running.
Each worker, you mean?
Right, yes, like each worker like needs around 150 megabytes from your SMEM.
Yeah, but we can't say that this memory is entirely wasted, right? I mean,
so sorry, what is the question we're trying to answer though? I'm not totally sure I follow. Because to me, like, I don't think, I think this comparison, I don't know what this is trying to show.
It shows that like clustered mode is just less efficient because you have multiple processes and each of the processes needs around 150 megabytes more memory to run because of the copy on write or like a new allocated pages. So like we run the cluster mode because of the CPU of like much better CPU utilization. But if you run on maybe like 2 vCPU instance, maybe it doesn't make sense to run in the clustered mode. Maybe it just makes sense to run in a single mode and kind of save these 150 megabytes out of each worker basically that you have to run.
But shouldn't I be able just like sum up all PSSs and it will give me like total, let's say, real size of the memory usage without overlappings? And just
yeah. I think like from my perspective, like we are looking at the Puma master and workers and like we sum up PSS and like we compare the PSS with another Puma running in the single mode with this PSS. So like we saw 351, 381, 382, and we compared with 830.
Yeah, that was my logic as well. So
it's my logic as well because like I think like this difference between PSS and RSS in single mode is, as Matthias is saying, like we are likely sharing Ruby binary, we are likely sharing some shared libraries, and like they reuse the same memory pages basically in this context. So I think this is why we see this difference of like 16 megabytes in the second one, but I kind of agree with you. Like we should sum up PSS and compare with the PSS from the second one.
yeah, so that was my line of thought. Could you share the doc if you don't mind?
Oh yeah, sure.
If you want, I could share my screen. I mean, to not ask you to switch. Yeah, so
sure. Just a second.
Okay.
Go ahead.
Yeah, Google Chrome, which one? This one. Yeah, okay. So, and yeah, I wasn't able to fix metrics for a single mod. I'm not sure I need to spend some time to fix it, but it would allow me to measure everything under pressure, not to measure, to chart it. But I bumped a couple of issues yesterday. So
Alexei, what problem you had with metrics in the single mode?
I just stuck in debug. So should I start measuring on master start? Like, because I found like this whole hooks description quite I don't know, confusing because sorry, just a second. Yeah, sorry. So I found it quite confusing. So this hooks description, should I start measuring the instance on master start? So which hook should I use? because most of the hooks I found in the code and in the description, they say only for clustered mode. And documentation is also kind of weird on this one.
I can answer you that question later if you want.
Okay, okay.
When we provide you a snippet to make it working, because it should be super simple, like to have it working, probably like one line change. So
okay.
If you want this working, like I can give you like some hint what to fix.
Okay, okay. So I started to look in Puma 50X also. So I built the latest Omnibus image from the latest master and applied Puma bump and also applied RB, how Camille asked. So feel free to use it. For me, it was like super fast to install and super stable. Everything worked as a charm. So, but the results about updated Puma are quite confusing also. So I see that in clustered mode, there is a slight difference in which the updated Puma acts better, but in a single mode, it acts kind of worse. It's everything on idle. So I need to measure it under pressure, I believe, to see less statistically skewed results. So I don't really know what to say about these findings because they're not like straightforward.
I mean, like about running Puma 5.0.
Yeah. Because
there are like new settings like Nokoyashi core, I think. Take a look at the experimental settings for the Puma 5.0 and try to configure them.
Okay,
and try to like measure like their impact, because there is like a new setting for the clustered mode to basically to fork, make the worker to be hot, and then fork from the worker second time to reduce like these 150 megabytes that we discussed before to much lower number. So
yeah, okay,
but I think you should look at the experimental settings for Puma.
Okay, I will. So the question is, should we even measure idle usage of memory? Is it even like statistically correct? Like, is it okay to even have these numbers? Because it seems like it could be affected, right, by many factors. Like how garbage collector kicked into this moment, or maybe didn't kick in. So it may be really dirty data, right? Because we can't control so many factors of it, and that's why I'm a bit confused if this data is even like worth it, unless like it's 300 megabytes of difference.
I think there are like two states that are worth understanding, like the idle when you like fork into worker, because if this idle is like significantly lower than the runtime memory of like processing some request, why it is that? Like, do we actually do some expensive compute on this worker still? So then the question is like, how much memory this worker like needs to allocate, and like why it is allocating so much memory. So I guess like Nicola work on the snapshots could be useful, because maybe we could like get a snapshot of the master, get a snapshot of the worker after forking, get a snapshot of the after processing some requests, get a snapshot after processing maybe GPT to understand if memory is retained, or like if it's not retained, what it's being changed significantly. Because like I think that Puma experimental, they do this dancing with the forking from worker to actually reduce this idle memory. Sorry, like make this process more like the hot before processing any requests after the fork. So I'm just like, I'm actually curious from my perspective, like we fork, do we actually have to load another code? Do we have to change the state of the objects? And actually this is also something that I'm kind of like, it's interest for me, because maybe this would really answer like why we need these 150 megs more on the each worker after processing some requests, because like it's pretty big number really. I would rather expect more like in north of the between 20 to 50 megabytes, but 150 is like pretty big number, and I think that like we don't understand why it is 150.
Okay, so to conclude my report, I think for today I really need to make better sense of like these numbers, because I'm still a bit confused about this. And as Camille suggested, try experimental settings and see what we could do with them. And yeah, maybe I will connect with Nicola and we'll try to look into snapshots. So that's it for me. I'm stop sharing.
Who is next?
Camille, do you want to go ahead? Should I?
No, Camille, you're muted. He's talking,
Okay.
but
Okay.
Can you see my screen?
Yeah.
So I think I kind of finished with the Spring, and I don't really want to pursue that further. Like, it seems tempting if we can like preload, but I kind of expect a significantly more benefit. And actually, maybe it's like connected with the like Alexi, your work and snapshot investigation. Maybe we're gonna achieve much higher efficiency, because right now this efficiency is about only 250 megabytes, which seems like pretty low. I was expecting more close to about 500 megabytes if we would preload.
Are there any issues? Like, were there any? Did you apply any hacks to really run Spring? I mean, some dirty hacks or?
I mean, like there's a bunch of them very, very nice side effects, but there is also a bunch of the very bad side effects, like signal handling is broken, for example. So it's not, I mean, like I have it functioning, but I would say it's far from like considering this like production use. So it's more like an interesting like experiment to check like, it's easiest way for me to try the preloading. Basically, it works, but like it has some side effects, and I'm unsure like how easy these side effects would be to fix. But like it seems that like preloading today give us like around 250 megabytes. I mean effective, which is like very similar to like Puma single mode basically. I mean from different angles, so like totally probably could have around 500 megabytes. But like then, like when I applied Spring, Puma single, at some point I kind of got to like this 70% of the GPT overall score. I then like played with the zswap to check exactly the swapping. And I actually, I brought a few comments about like the swapping and why I don't think that any type of the memory compression and swapping is basically bad. And it's like we have too high limits to make it like kind of useful. I mean, like it's good for the experiment, but if you would have to like advise to configure swap on these small instances, it should be rather like 50% of the available memory at most. Because right now, like we may be heavy swapping, but not generating out of the memory condition, and that would be more appropriate in some cases. I mean, like I wanted to go a little further and like see what easy thing I can do. So I kind of saw that like Prometheus is pretty big. So I disabled Prometheus, Grafana, GitLab exporter, and Sidekey cluster. I mean this main process to like switch to the general Sidekey. And without a Spring, with the Puma single, without a swap, so like only Puma single and these services being disabled actually make it me to achieve like this 98%. So like the total memory like did drop by around 1 gig with the Puma single and like some of these services disabled. It appears that these Prometheus, Grafana, GitLab exporter, Sidekey cluster, they consume in total about I think 400 megabytes or 500 megabytes. So like Prometheus alone, like it consumes 180 megabytes. GitLab Exporter, GitLab Exporter, because it's Ruby processes, like uses about 50 megabytes. Sidekick cluster, because it's Ruby, it's also 50 megabytes. Grafana is also, it's smaller, it's probably, it was something around, I think, 10 or 20 megabytes. But like for these two processes alone, like we use 100 megabytes because of the fact that they are written in the Ruby. I'm unsure like exactly why they use so much memory, but we also run them in the context of the bundle and GitLab. So maybe it's the problem that we are loading too many dependencies as well. And like, and I noticed that like we actually have this very bad pattern in our code base that we share the code base across all the tools, even if these tools don't need another parts of the code base. So like I noticed that, for example, in the race context, we are loading deep sidekick cluster tooling that is used by the Bean sidekick cluster like exclusively, and it's never used by the race. So I guess our monolith, my like understanding right now, our monolith is not structured at all to be like to have this like clear split of the like usage patterns that you could like define. And our monolith has like different tools that are all like being served from the single like bucket. And this bucket is loaded in like race, basically.
Is that because of all that stuff is on the auto load path when you boot the app and then Rails just loads it all?
I think we are preloading Heap, like eager loading Heap fully. And like, for example, Sidekick cluster, it's in the lib folder. So I did not investigate that further, but like, it clearly seems to me that probably we could shave from the Puma and probably we could shave from the Sidekick and GitLab exporter and Sidekick cluster processes probably total about 200, 250 megabytes. If you would not load the parts of the code base that are not needed by these tools. And like when I look at the memory dump from Unicola, and I kind of also look at the size of the objects of the running processes. I, for example, saw that there is like, I mean, GitLab metrics instrumentation, it's not used, but it's actually configured for every, I think, model or like most of the objects for the instrumentation purposes, but like we're not using that. But like roots and API, they actually, I did not measure exact memory being used, but I saw like a number of very big objects allocated for handling roots and API, for example. And I'm not sure if this is something that we could somehow optimize or not to kind of reduce that memory. Maybe like in the side key, maybe there is some way to basically not load these roots and API content. I mean, roots totally with the controllers and the API and have these kind of paths like expansion to be much easier in much easier form implemented. Because like I did not measure, but I would kind of expect that this roots API may be inflating side key. Roots API, and I should add also GraphQL in the side key. Probably it's inflating these processes by 50 or maybe even 100 megabytes because we are loading that, and like we have these rules for the expansion pretty extensive. So I did not go further into that, but I will probably at least try to remove GitLab metrics instrumentation and see like if it makes any dent in the memory usage on the PSS after like starting the Puma in the single mode without any request. So kind of like idle memory and kind of like stop at that. So this is like my kind of aspects that I looked yesterday. What I kind of plan to do today, I want to switch to Omnibus with Ruby 2.7 because I want to actually check the malloc preallocation size. You Matthias, like saw yesterday that our malloc bytes limit, I think it's configured to 32 kilobytes, sorry, 32 megabytes, if I remember. But there is also this interesting about the freed pages. Like, I think that I saw the piece in the Ruby code base where it says that we are freeing pages as soon as they are free. So I'm kind of curious, like, why we are not freeing any pages at all? Because, like, from what I saw, like, after running GPT on the Puma process, after some time, the disk memory gets inflated. But from what I saw, it actually seems to be mostly be recycled, but the memory is not like recycled to the system. So like memory pages are not freed. So like we have this inflated process size, and so parts of that is like because of the Ruby heap, but parts of that is like maybe it's due to like malloc happening elsewhere. And I was thinking maybe some of these native implementations that we use, like Nokigiri, gRPC, maybe they have some like memory buffers that they use. Maybe there is like some GC finalizer that is not happening. And like maybe it's not that we are leaking, but like we are releasing this memory maybe never, because we are only using like the buffer pre-configured. And this is maybe why it inflates our memory over time, instead of like keeping this kind of like constant at some level. So I'm kind of like jumping between topics, but basically I'm kind of interested in these two aspects, like malloc preallocation size, if this is somehow can be tuned to much smaller value. But second, I want to check the ordering of the RB load to check if we load parts of the application after forking. Sorry, if we load parts of the application when Ruby, I mean, between a moment where Ruby is initialized, master is deciding to fork, and we are forking to serve the single request. Because I want to check if I can somehow force the Ruby to basically disallow loading code and assume that as soon as everything is ready, we are no longer loading the application, parts of the application. So like when you start the process, this process has like all parts of the all pieces already loaded. So we are not further loading any more code after forking. So I want to actually check if it's actually happening, because I don't know. I want to check if the ordering of the RB load. I want to check if this happens after the forking. But if I get the ordering of the RB load, I want to check if I can somehow concatenate all the Ruby files into single file and load this single file. I mean, somehow generated automatically, and load this single file like in the single run, basically, to not auto load any other code, like, or like.
Is that what Chinyu looked at as well before? A couple of weeks ago. Didn't Chinyu work on this as well a couple of weeks ago?
Yes, like I know that Chinyu looked at that, but from what I learned there, it was pretty challenging, like, to get it right. So I want to like do some like time box bite on that, probably like 2 hours, to see like how far I can get there. If can I somehow maybe let's say concatenate in the correct ordering all GitLab files, for example, if it's possible or not. So it's more like the trying out if this is like feasible, and like how it changes like the optics of like loading, preloading, the speed, but also like the memory allocation. So this is for me. Do you have
can you just keep sharing, maybe, because like, yeah. Okay. All right.
Camille, one more question, but sorry, Matthias, but you mostly restart the application, do a warm up request, and just get the data, right? During most of your experiments, you are checking the memory on idle, right? On after the loading happens. So do you run some GPT and then measure?
It depends. I'm testing all the scenarios basically.
Okay.
I'm testing like before fork, after fork, and after like firing help or like the dashboard, and then after running GPT, which has much bigger coverage. So,
Okay.
so I'm actually like testing that in different conditions, like to check like how it's basically changing over time. I'm just like, I'm trying to find like anything that would, let's say, dynamically allocate memory and retain that to the some objects. I didn't yet find it. And like after my investigation, I only saw the GitLab metrics instrumentation to be one. But like, I'm trying to reason like why we have this difference. And I'm trying basically different like paths to validate that. If there is like something, I don't know, showing some side effects.
Okay, thanks.
It's a little like all over the place. Like I'm just trying, I'm checking like the next ideas that pop up on my head. So I'm saying that I want to look at the RB, but maybe in 1 hour I figure out something different. I'm gonna be testing something different because that appear to be like more promising. So I guess like you can consider this, that this is like my perception of the things that I'm gonna be looking initially, but what I'm gonna end up with, it's unknown.
Okay.
Sounds like Star Trek.
All right, let me do my update quickly. It's going to be super quick. So I wrapped up looking to compaction yesterday because I didn't feel like this was going anywhere. I don't think it has any meaningful impact on memory use. So I kind of ended up kind of drifting a little bit into what Nikolai was doing as well. So I spent some time trying to understand like where memory goes that we allocate. So like one thing I realized was that I looked at different numbers based on what the Ruby VM reports. And there's different ways to look at it. And I think it kind of adds up as well with what Nikolai was doing with the tools he used. It looks like when we sum up the memory that's used purely on the Ruby heap through things like object space, or just by looking at the GC stats and like just doing the math behind how many pages are allocated, what does it amount to in raw megabyte terms, we only get to a very small fraction of the RSS, the process RSS, right? So we get to, I think, like 150 megabytes maybe, which I don't know if that includes objects allocated by the Ruby runtime. I think it does. So that's something I'm still looking into. But even if it does, it's you know, like apparently the vast majority of memory is allocated elsewhere. So I don't know what elsewhere means. So so where I got stuck yesterday was mostly how, and I think I need help with this. I try to research it a bit, but I didn't find a good answer. Like how can we look into like a raw heap dump? Like what is the memory used by the process? I don't care about what the Ruby VM thinks or the garbage collector sees, because clearly that's only just a small portion. I think like we should figure out where do these 500 plus megabyte go that are totally unaccounted for right now. Because all these tools that we've been using, like that I've looked into, whether it's like the object space stuff or looking at GC stats, and then Nikolai, you've also looked at the derailed and memory profile and all these things. They all use helpers that I don't think, at least not in all cases, include the entire heap space that is being used. I think in some cases it does. I think in cases of things like strings, it does. And that's like why I spent yesterday just a lot of time just looking at the Ruby garbage collector source code and trying to figure out how does it even like count this stuff? You know, how does it even report sizes and things so that we understand what's even included in these figures. For instance, like this iClass stuff, I think those are all Ruby internal. No, these are not Ruby, but there's like iMemos and stuff, which are all these Ruby internal things, and which I think, yeah, this stuff here, like 30% iMemo. So this is like the Ruby VM, right? And then there's the open question of the compiled instruction sequences. I think it could make sense to look at like how much memory goes towards that. But like my main question would be to you as well. How can we get like an outside perspective, right? I don't want to go back and ask the Ruby VM, what do you think we're consuming in terms of memory? But like, are we really consuming in terms of memory at the operating system level? And I'm not sure what the best way is to go about this. So I think it would be good to look into this. And yeah, I'd be happy to pair up with someone on this, which is all I think I've said down here.
Yeah, I'm happy to pair on it because I also struggle with the same problem. I'm not sure what is the best way to analyze it.
Yeah, I mean, I looked at,
I couldn't find, funny, like I switched to the rail, I tried different kind of tools, and I'll explain more when it's my turn, because it really depends how you like get that snapshot, because it really depends also when do you turn trace object allocations. So if you do it on the boot start, it will give you more information about allocated space. But if you do a snapshot on the runtime and enable like tracing those object allocations, it will give you only information about like new objects that were allocated, which is good when you're trying to figure out the new object that stayed for a long time, like I tried to do with those 3 snapshots and trying to figure out like what object strings lasted long, but it didn't turn any results. But if you try to like analyze everything in the heap, like most of allocations are just pointing to a null because they're not traced.
Right. Yeah. So what was I saying? So one thing I started to look at was, so you can use GDB to just take a memory dump, and it supports different formats as well. It's just a super low level API. So it will ask you like, what memory address do you want to start and stop, right? To take a memory dump. I have no idea. So we will have to figure out how to use these tools, and then also how to visualize the data, right? Because the binary heap dump, sure, like you can look at it with a hex editor or something, and it will tell you, maybe you will see, oh, there's a bunch of like these strings or whatever that we like allocate. So maybe something stands out, but it will mostly be like not human readable. So I don't know if it's time well spent, but so yeah, Camilla as well.
I don't think that 700 megabytes dump binary dump will tell you like, exactly, oh, right. Here it is.
And the funny thing is, like, if you search for like how can you visualize a heap dump, like all the content you find on Google is for how to do it for Java. So because there's really good tools for Java to look at, like Java heap dumps and stuff, but there's just no good tools for Ruby, unfortunately. The good tools for Ruby are all the stuff we're already using that only looks at the Ruby heap, right? So that I don't think, I mean, I'm not saying this will not get us anywhere. I think so actually that's a good segue. Let me switch to this, because this morning I spent, sorry, I just need to find it. I think it's this issue. No, actually, sorry, Nikolai I switched over to your issue and posted a bunch of stuff here. So, and again, this is, yeah, I think this is only what the Ruby heap with a footnote, because if you, so this is what the object space module tells us is allocated. And I think it depends on the type of, object, whether that includes individually malloc space or not. Like if you look at how mem size is reported for strings, so again, this is like all with like a big footnote, because I'm not an expert on the Ruby VM, but like it looks like this is actually the full string length in memory. So it's not just the object slot of 40 bytes or whatever. And I think the same is true for arrays, but not for everything. So anyway, so yeah, I looked at what so how is this broken down currently in terms of, oh, actually, you need to update this again. How is this broken down in terms of the types? So which types consume the most memory? And it actually turns out, I have a listing here, and I'll actually cancel this section. Yeah, so this is the ordering by size, and it looks like 50 megabytes on the Ruby heap are just, Ruby heap plus X, I guess, are just consumed by strings. So 50 megabyte, and then 36 megabyte by classes. And this is what I was just trying to update. Is I'm trying to drill down a bit more into like what is class. You know, there might be
memory profiler gives you more information about this, because you can find the specific location where those classes were allocated. Like you can see by files or
okay, good. Yeah, so maybe we should catch up individually
else,
so that I don't redo work we've already
done
elsewhere. But I think it would be good to know, like, if I don't know, maybe because maybe like 10% of this is a particular gem, then it would be good to know, like stuff like that. But yeah, it was it's kind of surprising, right? I mean, 36 megabyte is a lot. But then also like these generic things where this is not useful, right? I mean, it's like interesting to see that you know, 34 megabytes of hashes, like, but we have no idea where those are allocated. So which brings me to my next point, which is,
I'm kind of like Matthias wondering, like, if it doesn't measure like this object and or like let's say deep objects that are primitive ones, because like for example class, maybe it measures like the I sequences of all methods, but maybe it measures the instance variables assigned to this class object. So I guess you would have to basically try and play with the class and make like a different amendments to this class. Maybe like adding some Ruby methods and checking like if the mem size of changes, maybe setting instance variables. I mean, the class variables on this class, and check if it's also changing.
I mean, I can tell you what I've been looking at a lot, because this method does that. So this is mem size of. It's a bit, it's actually pretty readable, like if you look at it. So, so the interesting, so like the base case almost is, you know, like this does not include strings, by the way, but if you have a ordinary Ruby object, like an instance, right? Then the size of is the slot size plus the number of instance variables, which makes sense. And this is the case you just mentioned. So if it's a class or a module, it's the same thing. Because the class is a module, then this is what it does. So yeah. So it's definitely more. It's not just the instance variables. It's more than that.
But it's very likely like almost everything, right?
Yeah, it doesn't look like it's not recursive, right? So if you ask an object for, so mem size of does not, just by looking at this, it's not recursive in the sense that it will try to like traverse the entire object tree and then, you know, like count them all towards your nested, you know, object that you're asking for. So it's flat in that sense, but based on the type, it includes different things. Yeah.
I'm kind of thinking like, because like, sorry, I am jumping between on different topics. Like you get at the dubs of the strings. Like, I wonder how many of these strings are frozen, and if we could somehow write an extension to Ruby to dedub frozen strings in the memory.
Yeah, because that was interesting, right? I mean, I only posted the top 50 here.
Because like I mean, like if the string is frozen, like you are not allowed to change that string. So it means that like you could kind of reuse that same object in multiple places.
Yeah, I thought this was funny that like the line break string, we have that in memory 8,000 times.
I know, but like if the slot waits like 40 bytes, which is like the lowest number that you may be using, probably 48 or something like that, it's around, it's almost like 300 kilobytes only on the new lines.
Yeah, that's interesting.
Yeah, but for example, that string is not introduced by us. It's
no, you're totally right. I mean, this could be, yeah, exactly. Like this could be in a gem, like for all we know. Like
I posted below your comment, but I'll show later. Never mind. So we can continue discussion.
Yeah, and I was just like, isn't there like a way to? I thought there was like a Ruby built-in way where you can tell it that only keep one copy of this string. I thought it was intern, but that's something else. Right?
Minus in front of the string, which is like the duplicate.
Minus
In front of the string, and it's gonna deduplicate the string.
returns a frozen, possibly pre-existing copy. Oh, cool! I've never seen that before. Interesting.
Yes, but like if you would have to like do it on the Ruby, and you would like to deduplicate all existing ones, you would have to likely write an extension to Ruby.
Yeah.
Probably in context of the, I don't know, GC dedup something that would like iterate all objects in the Ruby, and like fix the references and like unlink this reference. So I guess like it's more tricky like to deduplicate, because you would have to find, I mean, you would have to write it in the native. But I guess like this is why I'm asking, like, because if this is 50 megabytes of the strings that we have now, and if it says that like these 50 megabytes are frozen strings, maybe can we really kind of reduce that to, I don't know, 5 megabytes in the total if we deduplicate these frozen strings internally. I mean, there is also like the question about like these paths being used: Ruby, RVM gems, Ruby gems, Gitali. This is like also being stored in the Ruby somewhere.
Right. We can look at that.
I'm just also wondering like how much these paths really also consume the space. I mean, like you have these fully like absolute paths to the disk when you load the source location.
Okay. Yeah.
I mean, for the backtrace purposes. So I'm just kind of thinking like how much like these paths also consume, because we have a lot of files basically that we are loading as well. Yeah. So I guess like optimizing the strings usage probably could be something that can bring us pretty nice like memory improvement.
Well, 20 megabyte, right? So it's kind of capped. So 22 megabyte are duplicated. All other strings are unique. So it's a little bit. It's not massive. But it's per, well, outside of memory sharing considerations, it's per process. So could help at least with Sidekick as well, I guess.
So like
this is, by the way, from just to be clear, this is from, I took all my measurements in the same spot, which was just after master. It has preloaded the application, and just before we fork into a worker. That's where I've been pulling all this data so far.
So I'm kind of thinking like maybe these like full absolute paths for the source location, maybe they are consuming a few more megabytes, and maybe we can save that amount for the backtrace purposes. Maybe we can somehow optimize that part to be.
Yeah. So before I want to get into, I want to make sure we focus on the right thing. I think 22 megabytes doesn't sound all that juicy to me. I think what I want to focus on right now is this. This is like crazy, right? So we just looked at the RSS, worker RSS, just before we did a single page load is 800 megabyte. But the heap size is only 134 megabyte. So I think we should understand, and deep duplicating strings, that might take us days, and it will shave off 20 megabytes. It's really not that meaningful. Like, but where do the remaining 600 or 700 megabyte go here? I think that's what we should really be focusing on. Like, at least understand what is that memory even be used for. That would be my next proposal, which, by the way, is, and Nicola, maybe we can talk about how to best go about this, or what you have done already. But so one tool I wanted to look at is this Systemtap. It's old, but I hope it still works well, but it's really, really cool. It allows you to, there's actually a tutorial, it's 8 years old, so I hope this will still all work. But it allows you to, it has like this like DSL that you can write probes. And these probes, you give it an executable, and you can like tag methods, like native calls that the Ruby VM might be performing to hook into it, and then you can inject code and observe what's going on. So you can then do, so in this tutorial, he does stuff like counting. So this is like kind of a top of like you know how like the process top tool, but for function calls in Ruby. So he kind of wrote this just with this step tool. So you can see like, you know, for this process, so many calls happen to IO write, right? So maybe we can hook into this by, if we look at how the GC works, and it has a allocation function, right, for every object that is being requested to be created. So maybe we can write a Systemtap probe that intercepts these, and we see exactly from where these come, because this might be complementary to the work Nicola did already, because so far we've been mostly looking at breaking down, or what memory profiler does, break down by file how many bytes allocated, but not really also how often we do that, and also not, yeah, and I'm not convinced it includes everything, right? Because clearly the total sum it returns to us is much more smaller than the actual memory we consume. So I don't know, it's like one of these things that it might take a lot of time, and I don't know what will be the outcome of this. Maybe we don't find anything conclusive, but I thought it might be interesting to look at. Yeah, I think that's my update.
Can you stop sharing so I can share my screen?
Mm-hmm. Is there like a hotkey to stop sharing? Because I can never click this button here. I have to go back to turn the meeting and it stop sharing. There you go.
Okay, so yesterday I also struggled with analyzing this heap. I tried different gems. I tried this happy gem, and I also tried this heap analyzer tool that is giving us a good visualization, like the percentage of objects that are stored, but it doesn't give us, like, it's fancy, it looks nice, but I didn't get good info. Like I'm still struggling with the same question that Matthias is asking: how can we analyze this raw heap dump? So, for example, Hippie, like, give us a good tool to analyze everything, but most of the time I'm still struggling, like, extracting the useful info. And I also noticed that it really depends when I turn on the trace object allocation start, when I'm getting the actual heap snapshot, because if I turn it before the application load, like, I get a lot of information about allocation files, types, and everything else. And these tools gives a lot more information. But if I do it with arbitrace and run it just before I take a snapshot, then I will get just the new allocation, which is, as I said, good when I try to see, like, only the new objects that are being allocated, and maybe live long enough if I compare 2 or 3 snapshots. But beside that, I couldn't find any info. And I was also struggling with taking the arbitrary snapshot from the production virtual machine instance, because I often get the timeout waiting forever response. I tried, like, extending the timeout, it works, but it happens that the actual file is corrupted. For example, last few lines are missing, so I'm never sure if the snapshot is complete or is not.
So sorry, what do you do with arbitrace? What is it? What do you call with arbitrace? Can you quickly show how you use that?
If you remember, you were looking at yesterday, like, I'm like starting the new thread that is calling this object space trace object allocation start. I'm calling the garbage collector, and then I'm taking the
why do you need
snapshot in arbitrace, and I'm connecting to the actual
sure,
Puma.
but why do you need arbitrace for that is what I don't get. I mean, we can just hack on the sources, right? And just change the sources? to start
What?
and stuff like that?
Sorry.
So why do we need RB trace for that?
I think just to make sure that we're like to connect to the actual Puma worker and get the info at that moment. But I think that our documentation also referring to that. So I tried 3 different approaches and they all giving me the similar results. So I'm really not sure to answer you that.
Do you know, what does Heap Analyzer say is the total memory consumed? Is it also in this 150 megabyte region, or is it totally different?
something similar.
It is. Okay,
yes.
so that's good at least. So at least we
yes,
have
yes, yes. So I was also wondering why is so small. So I thought maybe it's because I'm using arbitraries. I try to use it like snapshot differently or directly, and yeah, on application load and everything else. So yeah, I'm still like I don't know. I don't have an answer how to analyze this heap dump or what is the best way to look at it. So I moved away from it and I tried to run those derailed benchmarks. Like derailed had a lot of tools, and one of them, which is cool, is this static benchmark. It's analyzing the memory used and objects created on required time. So it doesn't boot your application, it just requires the dependencies. So it can give you really nice information about like each of the gems, and it does whole memory profiling thing around dependencies. So it gives you the full picture before the application is actually started. So I got, if we take a look at the strings, like I got the similar list, but I need to say again, this is like the static benchmarking. So it just analyzing the objects created at the required time. So these are mostly the strings and objects that are not created by our code and our files. So I got the really similar list. These are the numbers that this is appearing, and this is the summary. Like I cut off the small appearances by 1, 2.
Wait, is that all the new lines that we were
like
seeing?
this summarize
it is the
this
string
one
report.
Yeah,
it is that's cool. Yeah, okay, so that adds up with what I was showing earlier.
Yes, it adds up.
Okay.
But the interesting thing is that dynamic like the derailed sorry, I cannot switch the tab because of the zoom. Derailed have this dynamic benchmarking, which is really cool because it can start your application and it can keep hitting some endpoint and do the same memory like profiler and give you the summary of memory used and objects created against your running application. And it has, give me a second, it has few really nice benchmarks. Like it can give you the summary of allocated objects, which will give you the same summary you extracted from the snapshot, like the classes and how much space they like all the objects that are allocated, but summarized by type. And also you can run this perf mem thing that will give you the summary of each gem and each file, how much memory it consumes. This one will give you actually the profiler info, like when you run the memory profiler, where you will get the summary of all allocated and retained memory per file, per class, per location, and also summary of all the strings. Interesting thing is that summary of the retained and allocated string is totally different than when we run the static one. So those strings contains, as Camille said, some paths that we absolute paths that we use, and some strings that are pointing to some Google classes for some gems and etc, etc. And it has this cool thing that's called mem over time, which is like hitting your application and showing you how the memory increases over time. So you can see like how much memory has increased over time, and maybe to detect that you have some memory leak or like how it's behaving. So this is all cool to run, but there is a problem. I cannot run it, like I was able to run it locally, but I can run using GDK only on development environment, which includes a lot of different gems than in production environment. Maybe like running it in GCK will be better. I also tried to like spend some time to like make it run on the production virtual machine instance, and I fixed a lot of things, but I'm keeping error, like it failed to connect to the Postgre while application is working correctly. So I tried playing around and like setting the password for the GitLab user on Postgre and updating and reconfiguring configuration and some different things that I found on internet, but I failed to run on virtual instance. I'm not sure if is it worth like spending more time trying to run it on like production similar environments, since it will give us a lot of useful information, or maybe we can just switch and try to use it on GCK.
Sorry to interject. So these benchmarks, we run them in CI. So I don't think we need to run them locally even. They run on, I think they run on every CI job one, or you can trigger them on CI.
Well, so that's cool information. I didn't know that. I didn't know that we use relays on CI job.
Yeah, actually you could pair with me, because I think I set it up some time ago, so I could remember something about
nice.
it in production.
Awesome. So I posted some of the info about all of this in this two topics, but I think that I should update the information about allocated and retained objects and memory used based on the production information, not my local environment, because it can lead us to the wrong direction. But each interesting thing is that I also noticed the GitLab metrics instrumentation in a lot of cases, and Gitally is also appearing a lot. But I still need to look into more details. But for today, Matthias, I can pair with you. I can pair with Alexei to make these CI jobs run derailed benchmarks on production. And
okay, we'll look into it.
Yeah, that would be really good. And then after that, I can maybe focus. It sounds interesting to me to take a look at GraphQL gem to maybe remove it and measure how much memory it takes and see if we can do something about it, so it like that we don't load it for Sidekick or something else. So I'm not sure like in which direction we want to go, but this is something that I can take a look next.
One thing I wanted to mention is because we're collecting a lot of data and some of these issues are getting super unwieldy. Like if you have to scroll past like, several screens worth of logs, there's a super helpful markup tool, or that's not a markup tool, but you can embed HTML into your issues or comments.
Yeah, you mean that expanding thing, like you can click and expand it, huh? Yeah, that's cool.
It would be cool if we can start using that, because some of these issues are really hard to navigate.
Yeah, I will update and add that, because yeah, there are a lot of logs.
Thanks. Cool. All right. Anything else?
Yes, I have like the last question on our agenda. Like we are around like the midway of the week. Like, what are your thoughts about like this format so far? Like, what we should maybe do differently for the second part of the week? I'm happy like to take this asynchronously if it's needed, but I think like we actually have like the 3 days left, so we may kind of like adapt to the last 2 days on like based on the pure 2 days that we have. So that's a question for us, like to think maybe now or maybe like for tomorrow, whatever feels suitable.
Okay, maybe, yeah. I would probably like to pair, like that what comes to my mind immediately, like with someone to see how anyone else operates with the tools, because for me it would be useful.
Yeah,
See
I also think
how you do measurements.
Yeah. I mean, it's like yesterday I spent a lot of time just reading source code and documentation. I'm reading so many blog posts by Aaron Patterson. He's just amazing, and he's been like, if there's any topic about Ruby memory management, he has written about it. So yesterday I think, so I don't think I would spend like all my time pairing because of these things. Like sometimes I just want to like read up on something and try to really understand it. But I totally agree that I also felt like yesterday I got stuck at some point where I wasn't sure if I'm going in the right direction, but also I started noticing there was overlap, right? I started noticing that I was looking to things that Nikolai was also looking into, and it only occurred to me like an hour into it that, oh wait, I think Nikolai is looking into this as well. So we kind of need to make sure that we don't duplicate work, and then just like make sure we sync early on and that we don't do the same work twice, basically.
Yeah, true. I feel like I spend a lot of time on these heap dumps, but like I didn't figure it out much from it. So maybe we should constrain a little bit more on the time spent on things. And I don't know, I'm not sure about prioritizing things, because this is really a huge topic and there are a lot of things to investigate. And I don't know, looking and measuring things, like those reports are huge, and like heap dump is huge, and analyzing all like the strings, objects, it's cool if we are lucky, so something stands out and we can like figure out, oh, this gem is huge, let's remove it and try it, or like this string is repeating like zillion times and takes like 100 megabytes, let's try to see what's going on there. But I'm not sure if we have some more important work that we can help, like investigating why, I don't know, instrumentation is there, should we remove it? If we remove it, is it going to help? Like, because like that instrumentation is loaded, or like it's overriding every object that we have maybe that's more important than trying derailed and again reading all those reports. I'm not sure, just saying, because we have 2 days left. So
I think I see what you mean. Yeah, I also had a feeling that, so yeah, I don't know, it's sometimes difficult to say or to decide how deep do you want to go into something. Yeah, because some of the stuff is super time intensive, and then you're not even sure if it's worth it. Right? Like this whole string stuff, right? For instance, like there's like an upper like ceiling to how much this will ever gain us. So I'm almost thinking at this point that maybe I would be okay with, by the end of the week, even if we didn't have, I don't think we should focus necessarily on like having all the solutions by the end of the week. I still think that some of the insights we get out of it are going to be useful, right? I think we really need to understand like where we are spending memory, and then we can make a decision of how much is that, and then we can say, well, this is really chunky, so we should focus on that, right? And then in the like come next week, I guess, we can then go back and look at these results and that are hopefully documented by then, and then pick some of these things and actually try to improve them. So I don't think I'm going to spend time this week to actually like build anything, but I just want to like really understand like where our memory budget is kind of going. I think that
I'm kind of thinking that like there is like limited amount of the big things that like you can optimize and have like very big amount of the memory saving. Like there is probably like one of the outliners, and like we saw that with the Puma single. Maybe there's like another one, but I'm kind of thinking that really like the actual reduction from the memory usage will come from many small improvements. So like GitLab memory, GitLab metric instrumentation is like, it's maybe like giving us, let's say, like half a meg or like 100 kilobytes. But if we find many of these small improvements, it kind of adds up, basically. So I'm kind of like thinking that any improve that we find, it's good. I mean, like if it takes like very little time like to ship that, it's even better, because like we may save like this, I don't know, a few hundred kilobytes. It's actually a few hundred kilobytes left that we have. So it's like a meaningful improvement. And if we find 10 of such, it's kind of then becoming a few megabytes already. So I'm kind of like thinking that like any meaningful improvement that we can find that reduces, it's actually beneficial, even if this is super small. If it takes us very little time to ship that, like it's even better, because it's gonna basically like add up over time. So I kind of like in between, because like I'm with Matthias on understanding where this memory is like going to, but I think the direction is really like on understanding what aspects we can fix quickly, easily, basically as well. So maybe these strings, like it's something maybe like 20 megabytes to save. It's pretty big number. Like if you add to the two processes, maybe metrics instrumentation is like something that gonna save. Maybe like from that investigation, Matthias, you're gonna find another aspect that we can save that's gonna bring a few more megabytes. So I think like that it's not. I mean, it's good that we can show like some numbers, like reduction, but I think that it's even better if we have like 10, 15, 20 different ideas, like of if we would spend more time, we would fix them, and they would give us maybe this amount of the reduction over time. So I think this is like the outcome that I'm aiming for. I'm aiming for like actually running on the 2 gig, and I'm actually probably bumping my expectation right now on running without a swap on 2 gig. Right now, we still require a swap. But the second like is identifying the aspects of the GitLab with maybe the expected benefit and the complexity that we may focus like in the upcoming, let's say Q4 or Q5 or like Q1 of 2021, and kind of have a lot of these improvements. So Nicola, I guess like there is no easy answer to your question. Like it's really up to you. Like, what do you feel? Is it like the worth investigate further, or is it not worth? If you consider that this is like it takes a lot of time, and like you don't really have like a good idea what to do next there, I mean, like it's like you should figure out maybe and just change to another topic and try to investigate another area. Like whatever, I think like this format is like we do things that we would normally not do in regular work. So like do whatever it takes to like to learn the most out of it, basically, and like do it like in your way. Like pick the topic that is like interesting to you, and choose like what is like the most promising, or like what is the something that you would not investigate otherwise. I don't know. It's fully flexible. That's the whole point. Like we meet every day to like to share our like experiences working with different topics, basically, like handling maybe even the same topic but from the different perspective and different angle as well. So I guess like there is no golden answer from me, and I'm kind of like struggling as well, and I'm jumping different topics because I'm noticing that some topics are much harder like to have some outcome than others. So I'm actually finding like the topics that can bring some benefit at the end of the weekend can beat my understanding of that stuff. So I mean, I guess usually the best answer is like fail fast and move on. If I would say that differently. So like you mentioned metrics instrumentation, like if you want to test that, like feel free to test that additionally. Like, I'm not super attached to it.
No, I will stay with the derailed reports because I want to wrap it down, like to have the actual data so we can analyze it. I'm not sure what we will find there, but yeah, we will see. And after that, I will see. Probably will take GraphQL or something.
Cool.
I just wanted to say that it's hard to like prioritize things since we have only few days left and there are a lot of stuff to take a look.
And it's actually pretty great that we have so many different stuff to take a look at.
Yes, it is. Yes, it is.
I gotta jump off the call, but yeah, Nicola, maybe we can catch up after lunch.
Yeah, let's do after lunch. Ping me or I'll ping you.
Sounds great.
Okay, guys, have a nice day
soon.
or evening.
You too. Bye-bye.
Have a nice day. Thank you.
See
Bye.
ya.